Hey gang, Stat 1800. The focus of this week. Let me get everything set here. It's kind of off kilter a little bit. The focus of this week is to begin normal distributions. It's a probability It's a continuous probability distribution. Last week we looked at discrete probability distributions. So we're kind of shifting gears. But before we get into normal distributions, I want to put up a quick video on a review of discrete and binomial probability distributions. Now guys, again, remember, think about the difference between discrete and continuous. It's the same thing as the difference between qualitative and quantitative, categorical and numerical quantitative. So we're kind of focusing on the counts right now. So what I want to do, I want to keep this handy, but I want to go to my stat lab. And you can see that regardless when you're taking this, I put this up on 9/11, there's a probability demo. Now, it's not for credit. It's just for you to learn. So before we get into the normal distribution, I just want to step back for a couple of minutes and work a couple of problems just to make sure that we're all on the same playing ground with these things that we looked at last week. So what I can do on my end is I can go to preview and I can go to take a look at the problems and work them. So the first problem says we have a contingency table to the right easy for you to say, to determine the probability of events. And you can see that we have A and A prime, and that's typical notation for A and not A, and B prime is B and not B. Now, if we needed for some reason to open this in StatCrunch or Excel, we could, but I don't really think we need to. I think just get a just any kind of O calculator. Speaking of, I'm gonna grab mine and go from there. So the probability that the event is A. Well, you can see that A has two cases. It's either B or not B, but nevertheless we have 130 A's out of a total of, so I need to add up all the possibilities. So I have 60 plus 70 plus 80 plus 60. So it looks like I have 270, okay? 130 and 104, okay, cool. So the probability of A would be the number of ways we can get A, which would be 130, divided by the total of 270. So we would be, let's see, what are we doing here? 3 places. So I'm saying that this would be 0.481. And again, I got that by just taking 130 divided by 270. All right, the next question is the probability of the event A prime. And again, A prime just means not A, but nevertheless, when we look at the table, we just need to add the number of ways that we can get not A, which is 80 and 60. So I need to take 140 divided the total of 270, and I get 0.519. All right, the next question is going to be the probability of the event A and B. And you can see that this cell right here, the count of 60, is when you have the probability of A and B happening. Okay, now if I want the probability of not A and not B, I would look at the intersection here. Down here, it would be the same number, but it would be a different cell. It would be 60. So, guys, very simple. Just need to take 60 divided by the total of 270, and I get 0.222. Now, the next question, the probability of event A or B. Okay, I don't think I covered this. Wow, okay, I could skip it or I could do it. I tell you what, I want to do this. So let me, let's go split screen here so we can get some. Well, All right, so when I have the probability of A or B, right? Guess what this is just this, there's a formula that allows us to do this, to calculate this. It's probability of A plus the probability of B minus the probability of A and B. So in this case, we want the probability of A or B. So we can see that the probability of A would be the number of ways we can get A, which would be 130 out of 220, and that's just found by summing up the row across A. The probability of B, we'd look at the ways of getting B. So I see 60 plus 80. So I would have 140 out of 220. And then the probability of A and B is going to be the intersection of the line A and the column B, which would be 60 out of 220. Now, when I put that in my calculator, I can do a lot of different things here. I can see that I have the common denominator, so I could just take 130 plus 140, which is 270, minus 60, which is 210. That doesn't seem right. Probability of B is 140 out of... oh, guys, I'm wrong here. This is 270. Okay, so so I could take 130 plus 140 is 270, minus 60 gives me 210 out of 270. So put that in your calculator, and we get 0.777. So 0.778. All right, guys, question number 2. If things seem like they jumped around a little bit, they did, because I had a video technicality going on, but we will get that taken care of anyway. Now, we did get it taken care of. You guys just didn't see what all happened. Number 2, the manager of a commercial mortgage department of a large bank has collected data during the last couple years. So it looks like the data is on 104 weeks. Compute the expected value. Now, guys, when you see in these discrete probability distribution problems, expected value, you should just think it's just asking you to find the mean. And the formula for the mean is to take the sum of the x values times the probability of those values with all the fancy schmancy subscripts that we see in textbooks. But that's essentially what is being said by the expected value. Now, what we got here is, if we look at the table of values, the number approved has to be either 0 to 7, and it gives the frequencies. It doesn't give the probabilities. But guys, what we can do very easily is we can take these x's and calculate the probabilities very quickly. Now, the x's range from 0 down to 7. So we can see that there's a frequency for zeros of 14, but that's 14 out of 104 weeks. So I can take, let me bring my calculator here, so we can have 14 divided by 104 is 0.346. Now, the question you have to ask here is, how far out do you want to go? I could round this to 0.1. I could round it to 0.13. I could round it to 0.135. I could round it to 0.346, and so on and so forth. Well, when I work a problem like this, I think how far I go out here kind of determines the technical accuracy I want. Now, this is going to be kind of a long problem, and I don't want to create a probability that gives me kind of a reduced technical accuracy where I end up missing the problem because of rounding. So, guys, I'm probably going to go out 3 places here just to be safe. So I'm going to put record the probability at 0.135. Now I'm just being a little careful there because I don't like to do work more than once. So again, when I enter that answer over here, part A, the expected value, I want to go far enough on my probability to where I get the right answer, or at least where it's counted right. The next one is 24 out of 104, so that looks like it's going to be 0.231. The next is going to be, you know what, there's a lot simpler way to do this. I'm going to show you how to do this right now. So what we could do is we could open this up in StatCrunch. This is going to be a lot better. And I can create a column of probabilities. And all I got to do is just go into Data and go to Compute and create my own expression. And my expression is going to be very simple. I'm going to do the number divided by, and we said what? It was at 104. And I'm going to press OK, and I'm going to compute. Now, what happened here? Oh, shoot. Guys, I messed up there. You guys are probably screaming at the I don't want the number, I want the count, the frequency. That was bad. Alright, so that's what we want. And guys, I want to get rid of that crap there. That's just ugly. So let me do edit and do columns and delete. And I want to delete probs, and I want to delete that silly column that I... Alright, so that's what I want there. Now the next thing I want to do is I want to take the frequency times the number. Because again, going back to the formula right here, we're going to have to create, forget the sum part right now, we've got to create the value of x times its probability. So that's going to be taking what's in column 1 times what's in column 3, and I'll store it in variable 4. So what I can do here is I can go to Data, go to Compute, do a new expression. So I'm going to build it, and I'm going to take the first times the frequency. All right, hit OK, and then build it, and there's a new column. Now, what I have now is I have these values for each of the x's. Now, if you I have some students that say, well, Dr. Darber, I just like to do it the long way. I like to, just do stuff. Okay, well, if that's what turns you on, go for it. I like to get things done as quickly as possible with as much technical efficiency as possible, and I know that the calculator in StatCrunch is going to be more efficient than me, because I have a way of turning that into like 0.513, doing something goofy. Now all I need to do now is be able to sum up these values, so I can go to Stat there and go to Summary Stat and do Column, and all I need to do now is just come down here. I need to take that column and just find the sum. And the sum is 2.808. Now let's see what they want us to round to over here. So 3 places. So we're going to have 0.2087. Well, that's not right. What did I say there? Guys, I think I'm losing my mind. StatCrunch. So 2.087. Gosh. It's awful early in the morning, I'll tell you, so I'm going to blame it on that. All right, now the standard deviation is a little harder to find. I mean, not much. But remember, the standard deviation is just the square root of the sum of each of the x's minus the mean quantity squared times the probability of x. So we got a little bit more work to do here to find the standard deviation. Okay, so I'm going to go over and again do this in StatCrunch because I think it's just going to be easier. So we know the mean is 2.0865, I'm going to call it. So the first thing I can do is create a value of these, and I'll sum them up. So I'll show you how to do that. Now, so I'm going to go data and go compute and go expression, and I'm going to build a new expression. So I'm going to start out with the value of x, which is the number approved, and I'm going to have minus the mean, which is 2.0865, and I want to square that, so I have quantity squared. And guys, I actually want all of that in a parentheses, so I'm going to well, guys, it's not going to let me do that. Shoot. Alright, if it wants to be stubborn like that, we'll just let it be stubborn. Let's go parentheses, we'll put everything there. So I want the x minus the mean, and I want that squared. And then I want to multiply that by the probability, which we had in the frequency divided by 104. So let's compute that. So we have a new column of values. So all I need to do now is come in and sum that up. And then I need to take the square root of that. So I'm going to grab my calculator and take the square root of that. So the square root of 2.1559726. Now, if we ask for the variance, that would be the variance right there. But we need to take the square root, and it wants us to go 3 places. So I get 1.468, hopefully. All right, so that question is done. So let's move on to the next question. A student is taking a multiple choice exam in which each question has 2 choices, assuming that she has no knowledge of correct answers, which means she's randomly guessing, which is a criteria to use probability strategies. She has decided on a strategy, speaking of which, in which she will place 2 balls marked A and B in a box. Gosh, wouldn't you hate to take a test this way? She randomly selects 1 ball for each question and replaces the ball in the box. The marking on the ball would determine her answer to the question. I actually took an accounting test once back in my first attempt at graduate school, or I'm sorry, undergraduate. It's kind of weird to think that I am where I am today with all these degrees hanging on the wall. I actually flunked out of college the first time. I played sports and stuff and had a good time, but finding that classroom was kind of difficult. So, but then when I went back, I was summa cum laude and straight A's in my PhD program. So I did okay when I went back, but my goodness, that first attempt was kind of crazy. So I can relate to this, where you might as well just pull a ball out of some sort of box. But anyway, okay. There's 7 multiple choice questions on the exam. Complete parts A through D. So what is the probability that she will get 7 questions correct? Now, guys, in previous videos, we have seen that the things that we need for the binomial distribution is we need n, we need x, and we need the probability of each question. Well, guys, the probability of each question is simple because we have two balls, so the probability is going to be 0.5. In this situation, n would be the number of questions, so that's 7. And we want to know the probability that she gets 7 out of 7 questions correct. So, guys, as I've taught before, what we want to do now is we want to go to Stack Crunch. Did I close that down? Now there it is. So I want to eliminate this, and I want to go to Stat and go to Calculator, and I want to go to Binomial. Okay, so my n is 7. My probability is 0.5, and I want the probability that x is equal to 7. So it says to 4 places, so it looks like 0.0078 would be the correct answer. I know I almost sound like the biggest dork that ever lived, but I think these are fun problems. I guess I just booked a trip to Las Vegas for next summer, and hey, you talk about a city that's built on probability, and I kind of like going out there. All right, what's the probability that she will get at least 6 questions correct? So at least 6 questions means that she'll get either 6 or 7. So we need 6 or higher. So gang, we can go back to Stack Crunch, same thing, and just do equal to 6 or larger. So 0.0625 looks like the correct answer. Next question was the probability that she will get no questions correct. That would be my luck. So we need 0, and we need it to be equal to 0. So 0.0078. Now, if you look at that, the probability that she gets no questions and 7 questions correct is the same because of the symmetry and the probability distribution. And when we go back, we can see the height of the bar for 0 and the height of the bar for 7 is the same because we have something that kind of looks like a symmetric distribution here, don't we? Well, it'll turn out that we will find some interesting properties that relate to something called a normal distribution that we'll talk about this week, as a matter of fact. All right, gang, what is the probability that she will get no more than 2 questions correct? Now, what's that mean, no more than 2? Well, that means she's either going to get 0, 1, or 2. So I'm going to go less than or equal to 2 in that problem. And I get 0.2266. And that's it. Guys, I think that's all. Just 3 questions. Yeah. Have a good one. That's all I got for you here.